Hi, in this video we will see what is the fundamental theorem of calculus, only part 1. There's another part 2 which we will learn later. What does it say? And we will do some examples. Okay, remember that if we have a continuous function, let f be a continuous function on an interval AB, and G defined as integral of that function f from a to x gx. Remember, this function is what we studied in another example. The fundamental theorem of calculus says that, so FTC part 1, I'll write it like that, says that this G is a continuous function. It's a law. There are a lot of information that it says that, well, don't worry about discontinuities. This guy is going to be a continuous function on the whole interval AB. It says even more, G is also differentiable on open interval AB. Differentiability is always on open interval. So that's the second piece. It is continuous, it is differentiable, and the third piece is that, and its derivative is given by, so not only says it's differentiable, it also says that the derivative of that function is just the integrand with that x. Okay, so this is fundamental theorem of calculus part 1. It says that what is the derivative of a function defined using the definite integral the way we wrote up there. So before I go do some examples, there's a remark here that you have to be a little bit careful about the notations, the variables here. See, when you define gx, what is important to note is that there is this lower limit is constant. This is a constant. Then the function, the integrand, it's a function, but the variable with respect to which we are integrating is, let me write box. It's a variable, so in this case is t. There is no other t in the bounds, anything else, just to make sure that the integral is well defined. But then there's another piece, that upper limit here is the variable with respect to which the function g is defined as function. And we are differentiating with respect to the exactly same upper limit variable. So these are three things that you have to note always. There is the integrating variable. It has nothing to do with the function. It will go away when you integrating. Okay. The lower limit is constant. Any number, a can be 0, 1, 10, any number that guarantees the function, the integral makes sense. Then the upper limit is one variable, and we are differentiating with respect to the same variable. Then, in that case, FTC part 1, so fundamental theorem of calculus, part 1 says that get the integrand and put in, instead of the integrating variable, which is now gone, put the upper limit variable, or exactly the differentiating variable. So this is fundamental theorem of calculus. Well, and you have to remember this and be able to use it. Okay, so here now I have some examples. Let's see what is the example. Okay, we have the function, different integrals. We are differentiating those ones. First of all, the integrating variable is t here, and you don't see any other t there. This is our integrating integrand, the function. Lower limit is constant. Upper limit is the variable, and we are differentiating with respect to that same variable. So we are then in the fundamental theorem of calculus part 1, which says that just write the function, the integrand, and then put the variable with respect to which the differentiation is done. That's nice. The second one is here. So this is our integrand, and the variable here, the integrating variable is x. So we have f of x here, and there's no other x. That's nice. Lower limit is constant. Upper limit here is y, and we are differentiating with respect to that thing. Three different things. This integrating variable. Lower limit is constant. Upper limit is the variable with respect to which we are differentiating. Then it says just write the function. Here is squared plus 2 times the squared minus plus 10. Write the function, but instead of putting the integrating variable in it, you plug in the variable, the upper limit variable. So y cubed plus 2y squared minus y plus 10. Here in this one, the integrating variable is x. The function is root 1 minus cosine tan x. And lower limit is constant. That's the second thing. Upper limit is exactly what we are differentiating with respect to. Then fundamental theorem of calculus part 1 says that you write the function, the integrand, but instead of putting in integrating variable, you put in the variable with respect to which the differentiation goes, or it is the same thing as upper limit. So here's t. Very nice. Here in this example, the integrating variable is t. The function, the integrand is e to the power minus t squared. Lower limit is constant. Upper limit is another constant. Well, there's something wrong here. In the fundamental theorem of calculus, upper limit is always a is a variable, and we're differentiating with respect to that. You see, we are still differentiating with respect to x, but there's no x in the upper limit of this integral. So this is not definitely fundamental theorem of calculus, because there's something wrong with this. I mean, I cannot use the fundamental theorem of calculus for this one. If you look carefully and you notice that, well, there is no variable x in the whole integral. So this whole integral, I don't know what is that. Actually, no one knows. You can approximate that. What this guy is going to be a constant c. And what we are looking for is derivative of a constant. It's not derivative of function of x. It's derivative of constant. And that derivative we always know is equal to 0. We'll do more examples for fundamental theorem of calculus, a little bit more complicated cases. But this is basically essence of what fundamental theorem of calculus says. It's exactly what it is, and then we will learn more things.